I hope you all can see my screen. Is it visible? Okay. So good afternoon all. Today I'm going to take up the session 7. So of Introductory Organic Chemistry second, which is a NPTEL platform course, and the course instructors are Professor Harinath Chakrapani and Professor Neeraja Dashaputre from ICER Pune. And I am your PMRF teaching assistant Simran. So today we are going to talk about conjugate additions, which is the week 7 course. So I hope you all have seen my previous lecture videos, and if you guys have any doubt regarding that, so please ask me. So first of all, we will taking up your questions only. Anyone has any doubt regarding the previous lecture? Guys, please respond. Okay, so considering that you guys don't have any questions, or so I'm starting this particular week 7 lecture. So it is about conjugate additions. So we are going to start with the problem 1. In the problem 1, the question is identify the following Robinson annulation product. So you guys have to identify what is the outcome of this particular reaction. So first of all, the condition of this reaction is base and ethanol here is the protic solvent. So guys, first of all, this base will abstract the acidic proton from the system. So you have to look which is the most acidic proton in this particular reactants. So here, as you can see, there is an hydrogen here. And if this base abstract this particular hydrogen, the carbon ion which is going to generate at this carbon will be much more uh, stabilized by the conjugation. How it is stabilized? The carbon ion which is getting generated at this particular carbon. Sorry, I think someone wants to join. Okay. So the carbon ion which is getting formed at this particular carbon will be stabilized by conjugation between these two carbonyls. So these two carbonyls will stabilize this particular carbon ion via conjugation. Here it is in conjugation with this particular carbon ion, and also same conjugation is there with this particular carbon ion. Okay. So this is the acidic hydrogen. So this particular base will now abstract this hydrogen from this position and will give you a more stable carbon ion at this particular position. Okay, is it clear till now why this hydrogen is more acidic and why it is abstracting this particular hydrogen only? Yes, ma'am. Okay, thank you for the response. Okay, so now after the formation of this carbon ion, what will happen here is, as you can see, this carbon ion is in conjugation. It is the conjugation stabilized. Okay, so now this species, how it will going to react with this? Is it going to give you the 1,2 addition or the 1,4 addition? There is two possibilities, right? Either this carbon ion will attack directly on this particular carbonyl, or it will attack towards this double bond, and then this will shift towards there, and this shifting will takes place, right? There is two possibility how it is going to attack on your particular species. Okay, so here, as you can see, that 1,2 addition and 1,4 addition are in competition. Okay, so what will happen? How it is justifying that this 1,4 addition is now going to take place? That here, this carbon ion, as it is stabilized by the conjugation, so now it will be acting as a soft nucleophile. What is meant by soft nucleophile? See, the you have to understand the concept of hard and soft nucleophiles, right? So what happens here is, whenever a carbon ion or a nucleophile getting generated and it is stabilized by the resonance, you will say that it is a soft nucleophile. So it will going to give you a 1,4 addition rather than the 1,2 addition. Okay. So here, in this case, the species which is a carbon and it is getting generated, it is far stabilized by these two carbonyls for by the conjugation. That is why here it is behaving as a soft nucleophile. So now, rather giving a 1,2 addition, it is going to give a 1,4 addition, and this is how this particular species will delocalize. So see here, this KOH, the base, first abstract the acidic proton from this position. A carbon ion is getting
Ma'am,
generated. Yes.
ma'am, kindly repeat that one. Soft nucleophile and hard nucleophile.
Okay. Okay. See, what I am explaining here is that first of all, when a carbon ion is getting generated at this position, just tell me that is it stabilized or not? It is stabilized, right? Via the conjugation between these particular two carbonyls. This one carbonyl and this two. Okay. So this
Yes,
can
ma'am.
conjugate between these two. So as this carbon ion is very very much stabilized, that is why it is behaving as a soft nucleophile. What happens here is, you if there is a carbon ion and there is no conjugation, right? What will you end up with is 1,2 addition, because now this carbon ion is behaving as a unstabilized species, and this unstabilized species will attack on this carbon. Just tell me that this oxygen has a small size or a large size. See, carbon and oxygen, if you compare going in the period, then you can see that this carbon and oxygen has a very small size, right? So what happens that this carbon, as it has a plus like partial positive charge and partial negative charge, so that is why this oxygen is behaving as a hard center, and it is also behaving as a hard center. Okay, so when this conjugation is going here, see, this double bond, when it is going here, okay, so now there is a partial positive charge which is getting created here. Yes or no?
Yes, ma'am.
Yeah. So there is a partial positive charge which is getting created here, and a double partial double bond character which is arising after the conjugation, I'm saying. Okay. So that is why now this nucleophile, which is now a soft nucleophile, can trap a soft carbon, like a soft center, very much. Okay. Now for that you need to learn about the HSAB theory. I hope you guys have heard about this hard, soft, acid, base theory. Okay. So on the basis of that, we can say that this center is far electron deficient, and now this carbon, as it is stabilized by the resonance, it is behaving as a soft nucleophile. So now it will attack on this particular carbon rather than this hard center. So it will attack at the soft center. So soft interactions and the hard interactions are playing role here. Okay. So that is why this carbon ion, as it is in conjugation, that is why it is just attacking as a 1,4 addition rather than the 1,2 addition. Is it clear now?
Yes, ma'am.
Okay. So someone wants to join, I think. Guys, please join on time. Okay. So if it is clear, then what happens here is, when this 1,4 addition is now taking place, you will end up with this kind of species, right? So now, as you can see that in the system we have this polar protic solvent, right? So when this oxygen ion is getting generated, I have told you that it will abstract a proton from this source. And now what happens here is, this carbonyl group again get generated, and this double bond get neutralized by the carbon. So now again this base will abstract a proton from this side, this H. So now, after the abstraction of the proton by the base, Now this kind of system is getting generated because as an enolate formation, it is now going here, and this carbonyl which is coming here down will again go up. Okay, and this kind of system is getting generated. So now what happens here is when this oxyanion again go down, this carbonyl, sorry, this double bond will trap this carbonyl, and it again goes up like that. And a six-membered species is now getting generated here. So this is how a six-membered ring is getting generated, and this is the carbonyl which is now going down. So this is how it is getting generated. So after the formation of this, see, either you can form a six-membered ring here or here. When you number it, this like this: one, two, three, this four, this five, and this six. Okay, so both the carbonyl will get you a six-membered ring formation only. Okay, either this double bond can attack on this carbonyl carbon, or either it can attack on this carbonyl carbon. So after the you will end up with the same species only because it is symmetrical molecule, right? So this kind of system is getting generated after the attack of this carbonyl double bond with this carbonyl. Okay, so now a dehydration process is now taking place to give you a alpha beta unsaturated ketone. We have already studied about this in the previous lecture that whenever you have an OH at this position, so it will rather stabilize like an alpha beta unsaturated center. It will prefer to stabilize like that only, rather behaving like an OH at this position. Okay, so now whenever you have this kind of system, a stabilization will take place by the dehydration, and an alpha beta unsaturated system is getting generated. So it is preferably getting generated, and that is why this is a driving force basically. As you can see that this alpha beta unsaturated ketone is far more energetically favored. Okay, as it is very much stabilized, right, because of the conjugation. That is why it is a driving force of the dehydration. Okay, so this is how this kind of product is getting generated. So can you tell me which is the correct answer among the three? So the correct answer is,
Second number.
sorry,
Second number, alpha beta unsaturated.
alpha beta unsaturated, yeah, but it is the first option which is correct. Just look at this. See, what happens here is you have another carbonyl also, right? So you can't miss that, and there is a methyl. Just see the positions of this particular thing and you can relate this is the particular answer which is correct. Okay, clear or not?
Yes, ma'am.
Okay, so if it is clear for all of you, then I'm going to problem 2. Okay, so in the problem 2, they are asking the major product form in the following transformation is. So here, now I can explain you very clearly about the hard and soft. You can get an idea about this particular thing. Okay, how a 1 2 and 1 4 addition is relatable. So they are asking the major product of this particular transformation. So first of all, look at the first condition they are giving. It is the methyl magnesium chloride, that is a Grignard reagent. They are treating it with a Grignard reagent. Okay, or as you can see that there is a magnesium metal which is present here, and they are coupling it with this copper chloride. So basically what happens in this particular step is, it is not the simple Grignard reaction which is occurring. Instead, there is a transmetallation which is first taking place in the system. How? Why there is a purpose of transmetallation? See what happens when you have a simple Grignard reagent and you just react with this particular kind of system with the simple Grignard reagent. Okay, so with methyl magnesium chloride, what happens here is it will end up giving you a 1-2 addition product, because magnesium here is a hard metal. So now it will attack to the hard center of the carbonyl rather than the soft center. It will attack on the hard center. So it will going to give you a 1-2 addition if you take up this Grignard reagent directly with this particular alpha beta unsaturated ketone. Okay. So now they are adding here the copper chloride. So what happens that there is a transmetallation which is now occurring between methyl magnesium chloride and the copper chloride. So magnesium is getting replaced by the copper. So copper here is a soft metal. See, lithium, sodium, potassium, magnesium, these are the metals which are hard. Why? Because they have the smaller size and the higher charge. So the concept of the hard metal or hard electrophile is that you have a small size and a higher charge around you. Then only you can say that it is a hard metal or hard electrophile. Okay. So hard electrophile will attack, will prefer to attack on the hard nucleophiles or hard electrophiles. Okay, so hard interactions are more favorable and soft interactions are more favorable. Okay, so now as magnesium is smaller, so there is a hard center which is present here. So it will prefer to attack as a 1-2 addition, because here carbon also having a hard center. Why? Because a partial positive charge is going to create on this particular carbon which is adjacent to oxygen. Okay, so the charges is not that much that much neutralized. So now what happens here, first of all a transmetallation step takes place between the magnesium and copper, so that copper will like displace magnesium, and now after the displacement of magnesium by the copper, you can say that yes, now 1,4 addition is going to happen. How? Because copper is itself a soft base, soft electrophile, and now it will add on this particular soft electrophile. Okay, so now here what happens, as you can see that methyl magnesium bromide is the methyl magnesium chloride we have here. So first of all a transmetallation step is taking place between the copper chloride and the methyl magnesium bromide. How? There is a magnesium bromide Cl which is going to give you a byproduct, and a methyl copper like thing is going to give you a soft nucleophile. Okay, so now this copper is a soft electrophile and now methyl is a soft nucleophile. So now methyl will attack as a 1,4 addition rather than the 1,2 addition, because it is the soft center and it is the hard center. So soft nucleophile will prefer to attack on the soft electrophile, soft center. So that is why a 1,4 addition is now taking place, and this methyl is now going to attach at this particular center. Okay. So now, in the first step, is it clear what is happening here? That this particular methyl copper species is getting generated, and this methyl is then attacking as a 1,4 addition, and this particular intermediate is getting formed. Is it clear from the first step only?
Yes, ma'am.
Okay. So now, if you have a Grignard reagent in the system, what will you end up is with a 1,2 addition or a 1,4 addition? If there is only a Grignard reagent present.
If only Krishna is then 1-2 addition.
Yeah, 1-2 addition. Very good. So now you will end up with a 1-2 addition rather than the 1-4 addition if you have a Grignard reagent only in the system. Copper chloride is intentionally added in the system. Why? Because a transmetallation step takes place, and now a hard electrophile get replaced by the soft electrophile, so that we can have an 1-4 addition step. Okay. So if it is clear that this kind of intermediate is getting generated, now what happens next? They have added.
Ma'am,
Yeah, yeah.
the 1-2 addition system will be only when Grignard reagent is added. But if it is the special case when we offer copper chloride or any other reagent, so that will be favored to 1-4.
Yeah, that will favor to 1-4. See, have you heard about the Gilman reagent? Right. What happens there? There is a R2CuLi system, right? That R is your nucleophile. Okay. So that Gilman system is that R2, you have copper in the system, and this Li. Li is lithium, right? So this is how a Gilman reagent look like. So what happens here? You can say that there is a lithium, there is a copper. So which kind of attack it will favor according to you?
Could you repeat that?
See, I'm asking that if you understand about the copper, right? So you have heard about the Gilman reagent, right? Right? That how a Grignard reagent work. We studied, right? That what is a Grignard reagent, what is a Gilman reagent? We have studied, right? So just tell me that if you have this kind of system, this R2CuLi, which is a Gilman reagent, okay? This R is a nucleophile. It can depends, okay? This R is a group, alkyl or any aromatic group. So, according to you, which kind of attack it will prefer? This it is a 1,2 addition it will prefer, or 1,4 addition it will prefer? Because there is two metals, right? You can't forget that this is a copper, this is a soft metal, and lithium is a hard metal. So, which kind of interaction it will prefer now? Can you guess?
Want to?
No, it will go for 1,4 addition. Why? Because you can see you have a copper, you have a center which is, see, your nucleophile is attached with the copper. This R is your nucleophile. Now it is attached directly to the copper, not lithium, right? So it will govern the reactivity of this alkyl rather than this lithium. So copper is a soft nucleophile as we have discussed. That is why it will going to give you a 1,4 addition only. Is it clear?
Yes, ma'am.
Yeah. So these kind of system you have to look very carefully that how your nucleophile is connected to which kind of metal. Is it a soft metal? Is it a hard metal? Or then only you can say that yes, now it is going to give you a 1,2 addition or a 1,4 addition. Okay. So I hope it is clear to all of you. If you have any question regarding that, just ask me.
No, ma'am.
Okay. So now look at this particular second step. In this second step, now after the formation of this 1,4 addition product, they have added in the second step the allyl chloride. Okay, this allyl chloride is just a substitution reaction, nothing else. What happens after this oxyanion come down? There is a negative charge now. If you don't allow it to react simultaneously, there is a negative charge now which is present in the system here, and as you can see there is no protic solvent present in the system which can give you the proton. Okay, so this carbon ion is now not going to neutralize like that. Is it clear? So that is why it will prefer to attack on this particular carbon, leaving the chlorine out, and you will end up with this kind of product. Is it clear?
Yes, ma'am.
Yeah. So now most tricky steps comes into play now. As I have not mentioned the stereochemistry now, but in your answers they are asking about the stereochemistry as well. They are asking you the product, but the correct with this correct stereochemistry. Okay. So now for the stereochemistry, you have to look at this particular thing that first of all, what we are doing here is first methyl will attack at this carbon. Okay. Now, methyl, if it is present at above the plane, right? If it is present as above the plane, if then the second nucleophile now, which is now attacking here, the stereochemistry of that center will be trans because of the steric hindrance. Okay, so now if the first nucleophile is adding at the above the plane, then the second nucleophile will be present at the dash plane, that is the below the plane. Because of the steric hindrance, this kind of system prefers the trans geometry. Is it clear?
Ma'am.
Yes,
Okay.
ma'am.
So now, if trans geometry, now if just tell me that if it is going to give you the this kind of trans geometry, is it the methyl which is more bulky or the phenyl which is more bulky?
Phenyl is more.
More bulky, right? So if you are showing up the methyl as in above the plane, then this phenyl is definitely dash. Okay. So if it is dash, then what happens that is this particular nucleophile, does it feel more conformationally stability lying below the plane or above the plane?
below the plane.
Below the plane. Everyone, see, I'm asking that whether if phenyl is more bulky, you are guys telling that phenyl is more bulky than methyl. Okay, if methyl is above the plane and phenyl is below the plane, now second nucleophile is getting attacked. Okay, so now that nucleophile, does it, sorry, that electrophile basically which is coming, does it feel more strain when it is in the plane of pH, that is the phenyl, or does it feel more strain when it is in the plane of methyl? In which case it is feeling the most strain, phenyl or methyl?
In the plane of phenyl.
Very good, in the plane of phenyl. So now if phenyl is below the plane, then the electrophile will prefer above the plane system. Is it clear or not, this statement?
Yes, ma'am.
Yeah. So in in this particular product, what you have to see is that this reaction how it is working, and also about the stereochemistry. See, which according to 4, which is the final product? Leave the stereochemistry, just tell me the final product first among the
Fourth
4.
one. Fourth
Fourth
one.
one, very good. Fourth one is the final product. Now here, if the phenyl is getting in the above the plane and methyl is below the plane, the nucleophile, sorry, the electrophile is trapping at the below the plane. Is it clear, the stereochemistry?
Yes, ma'am.
Yeah. So you guys have to look at that particular point also, that yes, which particular conformation is more stable for the things to be in the plane. Okay. So is it clear, the problem too?
Ma'am,
Yes, ma'am.
the stereochemistry I can't understand here.
Okay. See, when you got this, sorry, anyone has to say something? Okay. See, when you got this product, have you got the thing how we are ending up with this product?
Yes, ma'am.
Okay. So look at the stereochemistry. See, first of all, this methyl is attacking on this carbon. This nucleophile attack is taking place. So now you have to judge that which, this methyl and phenyl, they can't be in the same plane, right? It is a tetrahedral carbon, and this particular bond above and this down bond is in plane. This phenyl, this pH ring is in plane, right? So now you have to judge whether this phenyl ring and this methyl ring, sorry, methyl group, which is above the plane and which is below the plane. Just assign anything. Okay, we are not getting it as a rigid system. Now if I go with this methyl as above the plane and this phenyl if I go with the below the plane. Okay, so now the second attack which is taking place will be taking place at that particular stereochemistry which is more favorable. Okay, so if this attack is going to take place from below the plane, it will undergo the steric hindrance with this phenyl, because now phenyl is below the plane in the first step only. It is going to below the plane. Okay, so if this electrophile now going above the plane, then it will suffer the steric hindrance only because of the methyl. So which steric hindrance is more? Phenyl steric hindrance or methyl steric hindrance?
Phenyl.
Phenyl. Phenyl is more bulky than methyl. Agreed?
Yes, ma'am.
Okay. So that is why, as first step is have taken place, you have to judge that which of the group is above the plane and below the plane. If you are taking methyl as above the plane and phenyl as below the plane, second attack will be preferential now. This particular group will attack from that plane which is less hindered. So now methyl plane is less hindered than phenyl plane. So that is why it is attacking from above the plane. Okay, if methyl is above the plane. Okay, but in the product, how they are mentioning the stereochemistry, that methyl is below the plane. If methyl is below the plane and phenyl is above the plane, the second attack will take place from the less hindered side. And which is the less hindered side? The methyl side. Okay, that is why now the stereochemistry of this particular system is cis to this methyl and not to phenyl because of the steric hindrance. Is it clear now?
Yes, ma'am.
Okay. So I'm coming to the problem 3. I hope you all have understand this problem. Okay. So coming to the problem 3. So now they are the question is the identify the intermediate X and the final product Y in the given reaction sequence. So you have to identify X as well as Y. So first look at first of all LDA. This is the base which we have talked so much in the previous lectures, right? So LDA is a non-nucleophilic sterically hindered base. Okay. So here, first of all, they are treating this alpha beta unsaturated ketone with this LDA. As you can recall, I have told you that LDA will end up with a kinetic enolate rather than the thermodynamic enolate. Right? Remember or not? At least anyone say yes.
No, ma'am, I'm not attending the event.
Okay. See, my videos are available on the in my channel, so you guys can see that. So I am going to give you the gist only. I'm not explaining all the things again. So go and see that lecture. You will get to know. But here, what I have explained is that LDA, that is the lithium diisopropylamide, this base is a strong base, but a non-nucleophilic base. Why? Because it is sterically hindered. It is a very sterically hindered base, so it can only abstract the proton, but it cannot act as a nucleophile in the system. Okay, so you add LDA and you will end up with the abstraction of proton only. Nothing else will be done. Okay, so here in the case of LDA, you have to maintain the low temperature. Why? Because a kinetic enolate has to form. What is a kinetic enolate? Now, this system has protons like this is a proton which is acidic. Why acidic? Because now if you form a carbon ion at this position, it is conjugationally stabilized. Okay, there is a conjugation between this carbonyl. Then that is why if the carbon ion is getting generated at this particular carbon, it is stabilized. Now this hydrogen is also acidic. But if you form a carbon ion at this position, thus it will be stabilized. No, because this is the vinyl, sorry, not vinyl, it is the carbon ion which is getting generated at the sp2 center. So it is not that much stabilized rather than this conjugationally stabilized carbon ion. Okay, so LDA will abstract a more acidic proton from the system. So which is the more acidic proton? This is the more acidic proton, right? Because after the abstraction of this proton, the carbon ion is stabilized by the resonance with this carbon. Is it clear or not? Any doubt regarding this? Okay. So this particular carbon ion is now getting formed, and they have added the methyl iodide in the system. So what methyl iodide will do? As iodide has a partial negative charge and it is a electrophile. So now this electrophile will be trapped by this carbon ion, and this methyl is now placed here. Now they have added water. They have added water. Why they have added water? Anyone? This is the proton source only. It is nothing to do with this particular thing. These are the proton source only. So if any oxygen ion is getting generated, they will trap it and convert into OH, or the dehydration will take place. Okay, nothing else it will be done. So carbon ion will be trapped by H, and this anion is now neutralized. So this methyl is getting generated. This kind of system is getting generated in the end of this particular three steps. So x will be this. This will be your x. Is it understood?
So,
All of you. So this is what x is. First of all, LDA will abstract a proton which is more acidic. If you abstract a proton from this side, then only you will end up with a carbon ion which is resonance stabilized. And here, if you abstract the proton, there is no point of stabilization or conjugation. Okay, so that is why they are abstracting the proton from this side. And if methyl iodide is now trapped, then this kind of system is getting generated. So this is your X. This particular species is your X.
Ma'am,
Yes.
ma'am, how will we decide that where we have the stable carbocation or where from where I have to extract the proton?
See, if this carbon ion is getting generated, see, if this particular base will abstract this proton and this carbon ion is getting generated, thus it will be localized by the system. Just tell me that if it is in resonance with this double bond or this carbonyl, any of these,
No, ma'am.
no. So is it stabilized at this particular electronegative center? No. So if here a carbon ion is getting generated, it is how stabilized? It is stabilized by resonance. So whenever you have this kind of system or a carbon ion which is getting stabilized by the inductive effect or resonance effect, that will be the superior from the carbon ion which is getting generated at the absurd positions. Okay, so that is how you have to look at which is first of all you have to look at which is the acidic proton which is present in the system. Okay, how acidic? Because now you can see that this carbonyl has an electron withdrawing nature, right? So this electron withdrawing nature will make these protons more acidic. And also here, after the conjugation, this carbon will get a partial positive charge, right? So that is why it is behaving this hydrogen as a acidic character. It is giving hydrogen as a acidic character. That is why these two sites are acidic, nor these kind of sites are acidic. Okay, so you have to look which proton is acidic, and now if protons, one or more protons are acidic in the system, then you have to look after the formation of carbon ion which is more stabilized. So resonance, inductive effect, these kind of like minimal things are there to look and to figure out which is the more stable carbon ion. So you just have to figure out which is the more stable carbon ion which is getting generated in the system, and that is how you can say that yes, this carbon ion is getting generated. Is it clear? You have to look at the resonance, inductive effect kind of thing only. Nothing rocket science or nothing else you have to look at.
Okay, ma'am.
Okay. So, if it is not clear again, then please tell me. I will ask you. Sorry, I will tell you again. Just ask me how many times you want. Okay. So,
Okay.
this is X, which is getting generated in this system. Is it clear till now? So now, in the second step, what they are adding is this PHSH and in triethylamine. Okay. So now this PHSH, this triethylamine, what it will do here, as you can see, the sulfur has a lone pair of electron. It is nucleophilic system rather than electrophile. Okay. So now, if you have this kind of system, now you have to judge whether it is now giving you a 1,2 addition or a 1,4 addition. If there is a nucleophile in the system, then you can suppose that yes, it will trap this electrophilic carbon or it can trap this electrophilic carbon. Okay, there is two electrophilic centers which are present in the system. This carbon is not nucleophilic. Sorry, electrophilic. Why? Because after conjugation, a partial double bond character is arising here. That is why it is not electrophilic. This carbonyl carbon and this carbon at C4 position is electrophilic only. Okay. So now, if this PHSH is the nucleophile, can anyone tell me that is it going to give you a 1,2 addition or 1,4 addition? There is no
One
metal.
four.
Sorry.
1,4 edition.
Huh, very good. it is going to give you a 1,4 addition. How? Because now, as you can see, there is a phenyl ring which is present in the system, and you can see that this sulfur has lone pair of electrons, so it is delocalized in the phenyl ring. So that is why it is now stabilized. So this new lone pair of electron, as it is relocalized in the phenyl ring, that is why it is going to give you a 1,4 addition. Now it is a soft nucleophile. That is why it is attacking on a soft electrophile. Is it clear to all of you?
Yes, ma'am.
Yeah. If see, if anyone has any doubt, just ask me. Okay. You don't have to take up like if anyone has understood all the things. So why I am asking? It is not like that. If you are not understood, just tell me. I will explain it again and again. Okay. So this PHSH has a tendency to give you any questions. Okay. So after the 1,4 edition, which is
Excuse
taken,
me, ma'am.
yeah, you tell me.
Excuse me, ma'am.
Yes.
Ma'am, can you repeat this thing, ma'am? LDA, how this carbocation, this CH3I, it is attacking on that place?
Okay.
Second one.
This one, right? See, I have told you that LDA, the full form of LDA is lithium diisopropylamide. Okay. So this LDA is a non-nucleophilic strong base. It is a base. Okay. So what a base will do? It can abstract a proton or it can act as a nucleophile. Two things a base can do. But I have cleared that LDA is a non-nucleophilic base. Why? Because it is very sterically hindered. So it cannot act as a nucleophile. It can only abstract the proton in the system. So which is the more acidic proton you have to look at? So this protons and these protons. These particular proton as CH2 and this CH proton is acidic in the system. So there is a competition which proton is getting abstracted by the LDA. So if you abstract this proton from this side, then a carbon ion which is getting generated is now delocalized in the system. So a delocalization is taking place. Okay. But if you abstract this proton, what happens here? That there is no delocalization. Rather, also you will end up having a carbon ion at the sp2 center, which is not stabilized. Okay, that is why it is going to give you a proton abstraction from this side, and there is a carbon ion which is getting generated after the proton abstraction here. So this carbon ion, as you can say, that this iodide is partial negatively charged. It is a halogen, right? Halogens are electronegative in nature. So that is why this iodine will take up the partial negative charge, and this particular methyl will have the partial positive charge. So that is why this carbon ion is now trapping your methyl, and this kind of system is getting generated. Is it clear? Right, ma'am. Okay. Clear, ma'am. Okay. Thank you, ma'am. Okay, welcome. So this PHSH now going to give you a 1,4 addition, and this oxyanion species is getting generated, which is now take up the proton. Which now just tell me if you understood the thing. Then which proton will it take? Does your system has any protic solvent? No, your system doesn't have any protic solvent. So now what happens here is, see, this triethylamine doesn't have a proton to give. Okay, I know that it has a CH2 CH3 kind of thing, but it is not going to give you the proton. Okay, so now this what happens that this nitrogen have the lone pair of electron, as this PHS minus, if this kind of species is getting generated. Why? Because this nitrogen will abstract a proton from hydrogen of the PHSH. So now this thiol, basically thiol. So this thiol H is now taken up by the triethylamine, and this carbon ion is getting generated. So now, sorry, this is not a carbon ion, a sulfur negative charge is getting generated here, which is delocalized in the system of phenyl. So here, after the abstraction of proton from this thiol, this triethylamine will end up with a quaternary carbon, quaternary center. This NH with a positive charge on nitrogen. Is it clear? See, triethylamine is a very weak base. So it is not going to abstract a proton until and unless if the abstract after the abstraction, the anion which is getting generated is very much stabilized. Okay. So here in the system, it will abstract the proton from the thiol because now the carbon ion which is getting generated at the thiol is very much stabilized. Okay. Because of the phenyl ring, the resonance. Now this triethylamine will end up with Et3NH positive. Okay. So now this oxyanion and this negative charge, now this triethylamine NH will give you particularly this NH. Okay. Now this NH is present. I am not writing 83. So we can understand that 83 is there. So now this proton is taken up by this anion and again triethylamine is getting generated. Okay, so this is the proton source from where the proton is arising in the system, because we don't have any polar protic solvent in the system. So you can ask that yes, where is the stabilization which is coming from this particular triethylamine. Okay, is it understood or it is clear or not? Just tell me.
Clear, ma'am.
Okay, so you will end up with this kind of species. So which is the correct answer?
Fourth one.
Fourth one will be the correct answer. Very good.
Love.
Okay. So I'm moving toward the problem 4. So in the problem 4, they are asking which of the following is the anyone mic is on? Whose mic is on?
Sorry, ma'am.
Okay, it's okay. So they are asking that which of the following product will, uh, which is the product on the given sequence. So you have to figure out which is the outcome. Okay. So now you have this kind of 1,3-diketone in the system. So what happens here is this is the same kind of question which I have showed in the previous slide at the question 1, Robinson annulation. Have you recalled that? That this is the same kind of particular system. So if there is an acid which is present in the system, what it will do, acid will bind with this, okay, making it a positive charge. An oxyanion is getting generated. So how it is now getting trapped, that this proton from this carbon is now acidic. Why? See, if this oxygen will get up the H positive from the acid, what happens? This carbon is now more electrophilic in nature. Why? Because this oxygen will pull the electron towards itself. That is why this carbon is now much electrophilic in nature. That is why this hydrogen become acidic, and now this proton will going to give you this kind of system. A double bond is getting created at this position, and this OH will form. So again, this OH will come down, and this double bond will trap the carbonyl carbon, and this kind of system is getting generated. Is this much clear or not?
Yes, ma'am.
First of all, what happens? Acid will bind up with this oxygen, and after that, this oxygen will abstract the proton electron towards itself, and that is why this carbon become more non-electrophilic, and this acid this proton become acidic at the adjacent carbon, and this is how it will delocalize. And after the delocalization, this OH when come down, this carbon double bond will attack on the carbonyl carbon, and again this oxyanion is getting generated. Okay, so this is how you will end up with 1, 2, 3, 4, 5, and 6, six-membered species. So this oxyanion, as you can see that there is a acidic medium. So will it oxyanion will remain as O minus or OH? It will prefer OH, right? Because there is a acid which is going to neutralize the O minus. So that is why you are ending up with this OH. So this is the ketone. From there, you are having this ketone, and this is the system which is not changed. Okay. So now there is also again there is a tendency to form the alpha beta unsaturated ketone here. So a dehydration step will take place and you will end up with this kind of product. Is it clear everyone?
Ma'am, the third step will be mandatory or not, ma'am?
See, it is not always mandatory, okay? But what happens here that you can see that they are telling you that we have provided heat. So what happens when heat is there? A dehydration step is favorable very much. So they are intentionally giving a heat in the system so that the dehydration step will take place and an alpha beta unsaturated ketone forms. Okay. And also when you have not have the heat, it is very much stabilized that if you have the alpha beta unsaturated ketone rather than this alpha beta whatever you say that beta hydroxy ketone. Okay, this beta hydroxy ketone, if you recall, there is a name reaction in which you will end up with a beta hydroxy ketone. Which is that? Can anyone tell me?
Yes.
Aldol reaction, right? Aldol reaction in which you have the beta hydroxy ketone generation. Okay. So in that also, if you give the heat, then what happens? Alpha beta unsaturated ketone gets formed. Okay. So this is how this is a similar case. If heat is provided, then the alpha beta unsaturated ketone formation becomes more favorable. Okay. Is it clear?
Then it means the whole reaction it begins here, the carbonyl group which is outside the ring, right?
Yeah. Yes. Yes. The carbonyl carbon which is outside the ring will now getting this acid
Protonated
is
first.
yeah, this is protonated first. I'm not saying that if you do the like if you gave the stoichiometric amount of acid, okay, so everyone get protonated, but the thing which will be the first protonation will take place here is at this particular carbonyl only. Okay, so that is why the reaction is taking place at this carbonyl only. Okay, so this
Yes,
is
ma'am.
how the product formation is taking place. So which is the correct answer among three?
Third one.
Third one or first one?
First one. First
Yeah, first one. Good. So first one is the answer. So is it clear to everyone?
Yes, ma'am.
Okay. So going to the problem 5. So they are asking the major product formation of the following reaction. So guys, first of all see that there is also a base in the system. Okay? Sodium methoxide and methanol. Methanol here is the protic solvent. So if you have a base in the system, what it will do? It will abstract the more acidic hydrogen first. Okay, it will abstract the more acidic proton first.
Yes.
If the system has acidic proton, then it will abstract the more acidic proton first. So you can see that there is two possibilities. There is also a hydrogen which is present. This is also a methylene group, protons which are present here. Okay. So which is more acidic? Can anyone tell me?
Madam,
Yes.
middle one.
Middle one, very good. Because middle one is stabilized. If the carbon ion generation is taking
Carbonyl
place
groups.
at this position, then it will be stabilized by two carbonyl groups. But if the carbon ion formation takes place at this position, then it will be stabilized by only one carbonyl group. That is why the formation of this middle carbon ion is very much stabilized. Okay, so it is stabilized because there is a conjugation between the carbonyls which is 2. Okay, this one carbonyl and this two carbonyl. But if the carbon ion formation takes place at this carbon, then there is only one carbonyl which is in conjugation with that carbon ion. Okay, that is why they are abstracting the proton from this side. So now uh, this is also going to give you a 1,4 addition. Why? Because it is also the conjugationally stable. It is conjugationally stable carbon ion, right or not? This carbon ion, is it going to give you a 1,4 addition or 1,2 addition? Is it will add to this carbonyl or does it will add to this CH2? Sorry, CH.
Ma'am, CH2, ma'am.
CH2. Very good. Why? Because this carbon
More
ion
acidic.
is very much stabilized and it is behaving as a soft nucleophile. So it will add to up to the soft electrophile only. Okay. So I hope you guys have understood the soft and hard concepts. Why the nucleophile is soft or why the nucleophile is not soft. Okay. So, because of the conjugation and because of the resonance stabilization, this carbon ion is very much stabilized. That is why it is behaving as a soft nucleophile, and that is why it is going to attack on the soft center, okay, which is this methylene unit. So, this kind of system is getting generated after the attack, and this oxyanion protonation is taking place from the proton source. Proton source is present in the system, that is methanol. Now you will end up with this kind of system. Is it clear or not? This product formation? Any doubt regarding this? Okay. So problem 5, which is the answer? Tell me.
Third one.
Third one or the fourth one?
Fourth one, ma'am.
Okay. Fourth one will be the answer. So coming to the problem 6. So they are asking which are the intermediate P and the final product Q in the following reaction. Again the same kind of thing. See, you have to identify what is P and what is Q. So here you are providing the acidic medium to this cyclohexanone and this pyrrole. Sorry, tetrahydropyrrole. To so what happens here is, first of all, a protonation of this carbonyl is taking place. Okay, after the protonation, what happens? Then this lone pair of nitrogen will attack on the carbon, and here conjugation takes place. Is it clear to all of you?
Yes, ma'am.
Okay. So if it is clear, then this kind of system is getting generated because you are trapped with OH. Okay. So this is OH and this is the unit which is acting as. Okay. Now what happens here is that there is proton which is present, and a dehydration step takes place to the formation of this double bond. Why this double bond formation is favorable? See, what happens here is this double bond is now resonance stabilized. This is an inine kind of system which is getting generated. How? This lone pair is in conjugation with this particular double bond. This kind of conjugation is there. Okay, so that is why the formation of this double bond is favorable. So to form a enamine kind of system. So now this nucleophile is here. Can anyone tell me that is it going to give you a 1,4 addition or a 1,2 addition? Not based on the answer. Just tell me based on the knowledge you have gathered till now.
1, 2.
1,2 or 1,4. See, this is the nucleophile. This particular carbon is the nucleophilic center. So this nucleophile is now resonance stabilized with this particular nitrogen. Why? Because this lone pair of nitrogen is free for the conjugation. That is why there is a resonance stabilization of this carbon. And whenever there is a resonance stabilization in the nucleophile, we say that it is a soft nucleophile. So now what it is going to give you, a 1,2 or 1,4 addition?
1 2 addition.
1,2. Why? I'm saying that
Ma'am,
yeah.
ma'am, this there is a the other part of this carbon, the unsaturated compound. There is a double bond. So there, this double bond they undergo the conjugation with this carbonyl group,
Mhm.
and that carbon they will attack here on the second position.
Okay. So you are saying that this is in conjugation. That is why this carbon is going to attack there.
Yeah.
Why? See, if you go through the thing that you can say that this oxygen is has a carbon partial negative charge. This carbon has a partial positive charge. Now this carbon has a partial negative charge, and again this carbon has a partial positive charge. So how an electrophile will be adding on the nucleophile? Tell me. It is a it is an electrophile, right? This carbon. It is
Yes, ma'am.
electrophilic in nature. So
Electro.
how it is going to attack on a nucleophile? It is not possible, right? So what happens that a nucleophile is here only, and that is why it is going to attack on this particular electrophile. So if it is a nucleophile which is going to attack, is it the resonance stabilized? Yes, it is resonance stabilized. How? Because this nitrogen has the free lone pair of electron, and now it can come down and stabilize this carbon ion like this. Okay, and that is why it is going to give you the 1,4 addition instead of the 1,2 addition. So 1,4 addition takes place, and this oxygen ion is trapped by the uh, as it is in acidic condition, so which formation will take place rather than the oxygen ion. Okay, so now this OH bond will come down, and what happens that this again this carbon ion will be trapped by acid. Okay, which is present in the system. Okay, this acid, this will trap this. Is it clear till now? The trapping only, this kind of species is getting formed. Is it clear why it is going to give you the 1,4 addition instead of 1,2? Any
No, ma'am.
doubts? Sorry.
No, I couldn't. I didn't understood the
Okay. What exactly you haven't understood? Can you tell me?
one for addition, ma'am.
1,4 addition. Okay. See, in the enamine kind of system, see, this is the system which is known as the enamine kind of system. So we have talked about that whenever the nucleophile is resonance stabilized, we will say that it is a soft nucleophile, and there is a chance of having 1,4 addition instead of 1,2 addition. Are you agreed with this statement?
Yes, ma'am.
Yeah. So if you are agree with this statement, just tell me that there is a lone pair of electron which is present on the system. That is a new the nitrogen have the lone pair of electron. So it can come down and it can stabilize this particular carbon and which is getting generated. So that is why there is a conjugation between these the double bond and the lone pair of electron. That is why we are saying that it is a soft nucleophile, and that is why we are saying that it is going to give you a 1,4 addition rather than the 1,2 addition. I hope it is clear or not.
Yes, ma'am.
Okay. So if it is clear, then you will end up with this kind of system. I have explained you that if you have the protic solvent or the uh, acid in the system, then this oxygen ion will take up the proton and the OH formation will take place. And after the when OH come down, this carbon ion which is getting generated is neutralized by the acid. So this kind of system is getting formed. How? See, P will be your this system. This is what P looks like. Okay. So this is how P looks like. I mean this will be the P, because after P only we are going to give them the conjugate addition. Okay, so P will be this kind of system. Now if we are calling about the Q, then the second step they have treated it with the like hydronium ion. Okay, so here if you treat it with the hydronium ion, what happens that the hydronium ion H2O, from that the oxygen will attack on this particular carbon. Okay, this oxygen will attack on this particular carbon of the C double bond N, and the hydrolysis takes place, and that will lead to formation of a ketone. And this is how you will end up with this kind of product, and this is the Q. So, can anyone tell me which is the correct answer? Which is the correct answer? Answer option one.
First one.
Yeah, option one will be the correct answer. Okay. So coming to the problem 7. So they are asking which of the following does not undergo a conjugate addition reaction with butanamine. Okay. So for the conjugate addition to takes place, okay, which of them will not going to give you that? See, for the conjugate addition to takes place, you must have to have the alpha beta unsaturated ketone in the system. Agree or not? Everywhere seeing that there is a
Yes.
alpha beta unsaturated system on which the nucleophile goes to attack. For that 1,4 addition, you must have to have the alpha beta unsaturated system in the alpha beta unsaturated ketone in the system. So for the conjugate addition, there is a requirement. Okay. So just tell me which amongst them is not an alpha beta unsaturated system.
C.
Yeah. C is not an alpha beta unsaturated system. Why? Because there is no conjugation between
Conjugation.
this carbonyl group and this double bond. Directly, there is no conjugation. Okay. So that is why this is not the alpha beta unsaturated system which we can going to give you the conjugate addition. So this is the correct answer. This is a very straightforward question. Okay. Is it clear to everyone?
Ma'am, kindly repeat that.
Yeah. See, what they are asking is which amongst them cannot give a conjugate addition reaction. So consider this. What we have to require for a conjugate addition to take place, that you need to have an alpha beta unsaturated system on that a nucleophile can add. Okay. So if there is no alpha beta unsaturated system in the system, then what happens here? Does the conjugate addition will takes place? No. You will end up with a 1,2 addition only if there is no alpha beta unsaturated ketone which is present in the system. So first requirement for the 1,4 addition is you must have alpha beta unsaturated ketone or ester or aldehyde in the system. Okay. So just tell me amongst these four which is not an alpha beta unsaturated carbonyl group. This is C only, right? It don't have any alpha beta unsaturated system because this carbonyl double bond, so carbonyl group and this C double bond C is not in the direct conjugation with each other. Is it clear or
Yes,
not?
yes, ma'am.
Yeah. So this is why we are saying that this is not going to give you the conjugate addition reaction. Okay. So now it is, if it is clear, then I'm going to problem 8. Okay, guys.
Yes, ma'am.
Okay. So this is the problem 8, and this is the last problem of this session also. So what is the question here is what is the major organic product obtained from the following reaction? So they are asking that which is the major product which is forming in the reaction. So they are treating the cyclohexanone with this methylamine in, and after that they are giving the hydrolysis. Why they are going to give you the hydrolysis? Because after the formation of this enamine bond, they want again to hydrolyze that C double bond N bond to give you a ketone. Okay. See what happens here. It is very much similar to this kind of thing which we have previously talked about. This hydrolysis and this trapping. Okay. So here you have the methylamine. So what happens that first of all this methylamine, now if you are adding in the acidic condition, what happens? This protonation of this carbonyl oxygen will take place, right? So there is a positive charge which is going to get on this particular oxygen. This is how they have written there. So now, if this kind of system is getting generated, what happens? This lone pair of nitrogen will trap this carbonyl carbon, and this species is getting generated. After wrapping, this is going above, and this OH is ending up like this. Okay, and this is the system which is getting generated. Now what happens here is I have told you that this proton is being acidic and this dehydration will take place. Either this dehydration will can take place or this proton can simply leave out. Either this or either this proton can leave out. So you can see that either this proton will leave out and OH will leave out, going to give you a dehydration step like this, or after the conjugation with the enamine you can generate this and an imine get generated. Okay, this is very much similar with this system. I have told you that the dehydration will take place and this system is getting generated. So what happens here is a lone pair of electron is present on this nitrogen which comes down, and this imine kind of system is now getting generated. This. And after the removal of NH, because as it is a primary amine, there is a proton which is present at this nitrogen. So after the removal of this proton, this imine is getting generated. Is it clear till now? Till now.
Yes, ma'am.
Okay. So if it is clear that this imine is getting generated, now the second condition which they are going to give you is the hydrolysis condition. So what happens here? Hydrolysis condition, that the H2O oxygen will attack on this imine carbon and going to give you a hydrolysis product. So after the hydrolysis, this NCH3 will leave out as in methylamine again, and oxygen will trap here and a ketone is getting generated. So what will you end up is, as they are not showing the hydrolysis product, here they are showing the imine only, but after going to the hydrolysis what you will end up is a ketone only. Okay, so this is how imine is getting generated, and the correct answer for this particular thing is option see this
C.
D.
D, option D. Option D is getting generated. How? Because this methylamine will attack on this particular carbonyl carbon, and after the attack, this dehydration is taking place, and this kind of species is getting generated. So here, as this is the primary amine, so there is a NH which is now left here. So that is why this proton get expelled out, and this imine is getting generated. So that is why you are ending up with this kind of system. Is it clear, everyone? This mechanism? It is very
Yes,
simple.
ma'am.
Okay. So I'm just closing this session. I hope you have uh, gathered all information about the conjugate addition. I have tried to give you as much as I can give. So if you have any doubt regarding the conjugate addition or regarding the question which we have discussed today, you can tell me, you can contact me. Like, you can comment in the comment section. I will be uploading this session on the YouTube channel. You can attend the next lecture and you can tell me the questions. Okay, so I will take up the questions from you in the next session. So I'm closing this session for now. And thank you so much for attending the class. And thank you so much for patient listening and responding. Thank you so much. Because
Excellent.
if you guys are responding now, my work is very easy. Okay?
Excellent, ma'am.
Yeah.
Ma'am, the sessions which are done till now, are they uploaded on the YouTube, ma'am?
Yes, they all are uploaded in the YouTube channel.
Okay.
Yeah, so you can go there, you can check out the videos and you can learn. Okay, so guys, I will be taking up the last lecture in the next coming week. So on the next Sunday, 18th September is the last day of the session of this course. So I hope you guys have gathered very much, like, very vast information from this particular problem session. So I recommend and I request all of you to read out all the videos, so that in the last lecture we don't have that much spaces between the knowledge. Okay, so just go and read, and thank you so much for attending the lecture. And on the next Sunday we will be ending up with the problem session. Okay, that would be the last lecture. Okay, so thank you so much. I'm just closing the session. So guys, if you are asking about the book, then I think you should refer Claydon, Carothers, Skerian Serberg. For this purpose, you can go through that. Okay. Most preferably Claydon and Carothers. You can go through that. Okay.
Okay, ma'am. Thank you, ma'am. Thanks a lot.
Okay. Thank you so much.